Hello and welcome to my YouTube channel. My name is Jonesta and we are continuing on with a series of spatial data science using Python. On today's video we'll be talking about a little bit about GDAL because after last week's upload somebody just asked me what GDAL is all about. GDAL is a spatial library that allows you to convert between different spatial data sets because each person creates their own spatial data and it all has different formats. We have shape files, we have geodatabases, we have Geojson. All of these are spatial data formats. As you can see from this screen, GDAL works as a translator library for your geospatial data formats. I mean, we have so many geospatial formats, and at least most of us know the shapefile from S3. Then we have the CAD files. So you can see all these different formats of geospatial data. If you want to be able to ingest and use such different data formats on your web application, you will need to have a library that can be able to read between those different formats. For example, in this video, at the end of the day, we want to be able to get to read a shapefile on our Jupyter notebooks, and then we need to be able to convert that into a Geojson format that can be visualized clearly on the web using the Leaflet APIs. And because we can't really visualize a necessary shapefile on a web page, so we need to be able to have a format that can be displayed, and for that we will need to have GDAL installed. That's why we went ahead and installed GDAL last time. That's one of the bigger dependencies of any geospatial or web interface or software, because of that conversion and ingestion between different GIS formats. Another important package that we need to be able to read geospatial data is Fiona. Fiona, if you could just come here and search for Fiona Python, and then just let's see that. If you look at this, even on the PyPy organization, you can see it simplifies your usage of GDAL when you want to maybe open some specific file formats. Most importantly, for me personally, I like using Fiona to be able to open a shapefile, and then after we open it, we can be able to even edit a shapefile on our web page using this dependency. And now, again, this dependency is one of those packages when you try to install it on a Windows machine, it also releases an error like we saw last time with GDAL. And for that we need to be able, first of all, to get GDAL, then you get Fiona, and then you can be able to install a lot more other spatial packages. For this case, you can see we have Fiona 1.8.13, and we will need that so that we can be able to read the shapefile in our Jupyter notebook. So for that we will need to go ahead and then install Fiona. But if in case you are on a Linux machine or a Mac OS, you can be able to just learn this command pip install Fiona and you'll get the latest version of Fiona. But in Windows, that raises also an error. That's what we are trying to solve today. We will be able to install Fiona, and then we'll be able to install Geopandas we can be able to convert a table in the CSV file into a geospatial dataset using Geopandas and Fiona. Last time we created a virtual environment using ppnv, and I would like us to go and open the folder where we installed our ppnv environment. So for me, my environment was here in the folder of D. So here inside my spatial data science folder, that's where I have my pip file and the locked dependencies. So in this case, for me to be able to access the environment, I need to, we remind ourselves, we need to come in here, and we can be able to press your shift key and then right click on your mouse, and then it will pop up this that tells you the things you could open on this folder. So for me, I would like to open a PowerShell window here, so I just go right ahead and do that. And now the command to activate our pip env virtual environment would be like last time, because we have not started PowerShell as admins and Python is not installed as on our path. We need to type pi m and then do pip env shell. You can see it has launched pip env subshell, and if we come in here, we can do pip freeze. We can see, so that we can see the packages that we have installed. And you can see we have already installed one of the files, that's the GDAL. So the next one we need to install will be the Fiona file. Now for us to install Fiona again, we need to go to the site that I had shown you the other time. We come in here, we get to this education site, and then for me, I find it easier to just add hash Fiona on my search, and then I can be able to find where Fiona is. And now this Fiona file is, we need to select again, like GDAL, we need to select that file that is compatible with our previous install of GDAL. In our case, mine was the 64-bit GDAL, so I'll just go ahead and click that, and that now gets me a download of Fiona. So we download here, and then we can now, from my side, you can just go here and show in folder, and then if you do show in folder, it pops up this, it tells you where it is. Then you can come in here like we say the other time. It shows I had another previous download. I have the Fiona wheel downloaded here. So what I want us to do now, as you have seen, the Fiona package has downloaded. So I just come in here and click on and then get properties, and then I go to security, and I can be able to copy the path of my Fiona file. So after I have done that, I need to go back to my virtual environment, which I had already installed, and just do pip install, and then you paste the path to your Fiona file, and that goes ahead and installs Fiona for you. Once your Fiona package has been installed, you can go right here and see like before, pip freeze, and you can see we have Fiona and GDAL, which we have installed from our local downloads, and then we have other dependencies of Fiona here. So the other package we need to install to our virtual environment for us to be able to work with the spatial data, we need to install another one called Geopandas. This one requires dependencies. The dependencies it requires are the Fiona and GDAL. That's why we made sure we install GDAL and then Fiona first, and then we can be able to come here and start to install pip install Geopandas, and your installation, as you can see, it has installed Geopandas. So now I need to be able to clear my shell first, like that. Do type clear, and then I do pip freeze, and you can see now all the packages installed. Finally, one of the packages that I want to download today is a Geemap package. This is a new package by Google, and this package really helps you to interact between Google Earth Engine platform and your Python virtual environment. It's also the same package that has been ported to QGIS to work with Google Earth Engine data. So we're gonna be installing that also. So that again, it requires to be installed now. So we do pip install Geemap. Then that we install the various packages that we need. As you can see down here, the Geemap takes care of some of the packages we could have installed one by one. As you can see, it has all these packages. You could pause the video here and have a check on all these packages here if you want to know something more about them. And it's a lot of packages, but these are some of the more of the packages that we need to work with when we are working with geospatial data on our Jupyter notebooks. And it has also installed for us a Jupyter notebook. Here you can see let me see where it is. It has created for us a Jupyter notebook. See, there's a Jupyter client, and then there's a Google API for a Python API. That's what that interacts with Google Earth Engine. So if I need to be able to clear that, and then if I come here and do pip freeze, you can see we have a lot of packages. That these are some of the packages that we will need to be able to work with spatial data on a virtual environment. Now, most people I know prefer to use Jupyter notebooks to do the spatial data analysis. But for me, literally since the introduction of JupyterLab, I prefer to use JupyterLab over Jupyter notebooks. It's the same thing. They use the same data format for the IPython library notebooks, but I find JupyterLab more intuitive for me. But you can go, when you have reached this point, you can just leave your installation as such. But for me, I'll go up ahead and install JupyterLab, because I'll show you the difference between JupyterLab and Jupyter notebooks, so that you can decide whether you want to install JupyterLab. You can come in here and do start Jupyter notebook, notebooks, and then you can get sorry for that, it's Jupyter notebook, and then that opens for you Jupyter on your browser. So you can see we don't have anything on this folder. We have just the pip file and the log dependencies, because we have not created a notebook here. So we can go here and come and create a new Python 3 notebook. You come in here and change it to test notebook. You can name like that, and when you come in here, you can be able to type in to import all the packages that we have installed here, which we installed on this virtual environment. So you can type, and these are the cells that we will be using to work with our spatial data. Most people will be comfortable with using Jupyter notebook as this, but for me, I prefer to use the JupyterLab environment. It uses the same file format, but let me just say JupyterLab is more beautiful. It has more functionalities for me. So I'll cross this notebook here and then go back into my PowerShell, and then I do Control-C. That kills the Jupyter client. So then I need to clear so that you can have more space here. From here onward, pip is your best friend to install these packages. So for me to install JupyterLab, I'll come in here and do pip install JupyterLab. And you can see it's connecting JupyterLab for me. Once it's done, then I can come and light. Let me just first of all clear this so that we can see. Then we do JupyterLab. And then that starts JupyterLab environment for us. First of all, if it pops up this, it is telling you need Jupyter reference. It needs something to build. I don't want you to build it now, so I want you to just hit cancel, and you can see what I had told you about working with JupyterLab. Now for me, I find this is intuitive more than the normal Jupyter notebooks. So if you can see all the things you can do here. It's more or less like a web-based, I can say a web-based IDE for Python in my case. So this is the difference I was telling you. Like, then you from here you can do other things that I mean, we won't talk this maybe in a different video. We'll talk about the Jupyter notebook itself, I mean from scratch, and then but for this case we want to be able to use JupyterLab to just learn one notebook and be able to visualize our spatial data on our Jupyter notebook. So what I will do, I will just, because you see there's an issue that you are told about something needs to be built for hyperrefresh, so I need to be able to cancel that. And you can see from the installation site of JupyterLab, it tells you need to be able to install the extension to work with widgets of the Jupyter Refresh. So we just go right ahead and come in here and we copy this command, JupyterLab extension install. Then we install the refresh widget. So what I'll come back to my command line. So then I hit Control C. That interrupts my JupyterLab environment, and then I'll be able to install. And you hit enter, and let's wait for the JupyterLab extension to install our Jupyter Refresh widget. It takes a while to build our assets for the JupyterLab. As we wait for that to finish, we'll come here and I have a different folder here where I have my dataset. This dataset here is a shapefile of Kenya markets, and I'll come in here. I just want to copy the dataset, so I'll copy this here and go back to my environment here on Spatial Data Science, and then I'll just paste my datasets here. Now you can have any shapefile. I don't know what shapefile it is. Maybe it's be good to experiment. And you see, previously I had been able to create a Geojson file from this. So what I want to do, I want to be able to just delete the Geojson, and then we'll be able to create it on our notebook. So we just go check if our extension has finished. So here you can see the JupyterLab has built our refresh extension. So what I need to do is now do JupyterLab. That opens for me JupyterLab. So create a new notebook. So this time let's create you come here and you go file, new, do notebook, and then from here this is the kernel we want to use, the Python 3, and then you right click here, you can be able to rename the notebook, and this notebook now we call it Spatial Data Science. I can be able to rename that. Now that our virtual environment has been created and we have created our new Spatial Data Science document, so what I want us to do first of all is we need to import a few different packages. First of all, we need to be able to come on this cell and do import Geemap, and then you hit shift and enter. When you hit shift and enter, it executes the cell here, and then it creates for you another cell to work with. Now the interesting thing with JupyterLab and Jupyter notebooks is that on the IPy document, each cell is executed as a complete block of code that can also import other values from the preceding cells. So be careful when you change a previous cell and then learn another cell down here. For us to start to be able to visualize a map, we need to be able to do map and then just name it to Geemap, which is this package you have imported, then .map. The .map receives a number of arguments. One of them is the center, where you want the map to be centered. Then you can do centered is equal to, and that requires coordinates. So you do the coordinates in as a list. So you do center, and then the coordinates for here for me will be around the equator. So I'll do 0 as the latitude. This follows the latitude longitude format. So you do, and then you do the latitude for here will be 38.5. I want this to fit somewhere in the middle of Kenya. And then the other thing that I want to do is the zoom levels of the map that comes in. And then so the zoom level here I'll do a 6, that will be able to show me Kenya as a whole. And then once I do that, I can then again shift enter, and then I come here. I can do now, I need to be able to call this map object here, so I do map, and there we go. We have our map of the world centered to Kenya, and I mean it's a map of the world because you can zoom in out and out of the area, and then you can just go back in and scroll. And this is what I'm saying, the Geemap is a very intuitive visualization for Jupyter Notebook, so I love it. That's my opinion. So yeah, this is what you get for learning this. No, what we need to be able now is to build upon this map by adding more and more layers. The Geemap creates a very good, a very beautiful user interface for our map. So when it has all this stuff enabled, it has the search, the addresses. You can do just a name search and you can see Nairobi. If I do Nairobi and then just hit enter, and then you see it will give me a pop-up on where Nairobi is. Now that you have seen the power of the Geemap, you can be able to see, if I come learn here and then do that again, you can see the power of Geemap. Now we need to be able to display something on top here, and we have so many ways of doing that, but in this video we want to display just the markets, the marketplaces on this map of Kenya here. So one of the things we need to be able to do that, we need to import the other packages. So go back to the first cell here, and the next package we want to import is from the Python standard library. You do import JSON. That is for creating JSON objects. Then we go here, you need to be able to import Geopandas as GPD. Prefer to import it, you import the package and give it a name to be using this. This is convention for Geopandas in most spatial analysis workflows. And then the other tools we need, the tools to be able to visualize these maps on our refret. So we will be getting this data from IPy refret. Then you need to import our Geojson. And then another thing we need to import are the markers. Markers that will help us to we'll be able to show our data as markers on our map. Then we need another one which is called marker cluster, which we will need to cluster our data together. And then the final one on this IPy refret, we need to be able to create a pop-up. that we will use to show, so that such that when you click on a point on the map, we can be able to see the information. Now, another thing we need to import will be from IPy widgets. See IPy widgets, and from here we import HTML that will be able to help us make our pop-ups beautiful once we learn. And with this, we can be able to import all those packages there. It's telling me I have a problem with markers. Oh, it's not supposed to be markers, it's supposed to be a marker. You can see that. This does not change the map here, as you can see. So it just has our packages ready to work. So what I want us to do, I want us to go back to our folder that we have used, and you can see here I have the datasets that I copied. These datasets will be attached on the link below. You can be able to download the Kenyan market shapefile, and then once you are in this is the dataset. So this is the shapefile we want to read, and then once we read the shapefile, we can be able to visualize it on the map. Now that you have our map ready, it's time to read our shapefile into our map. So the first thing we need is to come here on this cell here. I don't want to create two different objects of the map, so I'll just come in here, and on the top here, once you can come in here and be able to either cut the cell or just delete it. There's so many commands here. So but the one we will be using today will be the insert a cell below. So that inserts a cell below our map object here, so you can do that, and then you can install another one, but for me you can do this. Now on this line here, we want to be able to read our shapefile. So what we need to do is read markets, just call this markets as the variable, and then you call Geopandas, that's GPD, which we had how we had imported it here. Then dot read file, and then that file will be, as we have said, it is here on our datasets. It will be in datasets, and then this is the shapefile we are reading. So you come in here and you get the path to your shapefile, so you can do that. This is where it is, and then once we do that, we want to be able to convert our shapefile into, so you can just do that, just hit enter, and I want to add more cells here. Once you create our markets, then we need to convert our markets to JSON. So we do markets dot to file, and then you give the name of the file. In this case, again, I want it still to be Kenyan market.geojson. So I'll come in here. So this is power of Geopandas. It's reading my shapefile, and I want to convert now this shapefile it has read into a Geojson. So I do that, and then I need to add in another argument, which is the driver of the file we are creating, which will be a Geojson. So we do Geojson, and with that, once I hit enter, I have converted my shapefile into a Geojson file. And if you come in here to your folder, you can be able to come in here and see we have our Geojson market file here. So even if you come in here, for me, let me open this with brackets. You can see this is the format, and then I can come in here, give it as a JSON, and then you can see the how it is, and you can see this is the Geojson file we have created. It's a feature collection with feature type, and it has these properties. These are the properties of my shapefile, which you can see we have properties county, you can see we have Baringo County, we have a market, the name, we have longitude and latitude, and then we have the data was corrected, and then we have the geometry, which now this is the spatial data that is being read by that should be read by our map. You can open this Geojson with any other ID you have, or even a notepad, but it will not be as looking beautiful as this. But so I open this with brackets. That's what I have here. So you can see some of the properties we will need when we are creating the pop-ups for the data here. So we go back to our notebook, and you can see we have created our Geojson file. Now that we have created our Geojson file, it's time to read it into our notebook. So we use the standard library of Python. So we use the with open. Then we need to open the file that we have created, our Geojson file. So you can remember it is in datasets, so we need to be able to create that, and then we want to open it as markets file. And then once we open it, we create our JSON data, which will be say JSON data will be equal to the package we downloaded, we installed at the standard library of json.load, and then you load our market file here. Once you learn that, now you have your JSON data loaded and ready to be populated into our map here. For us to visualize our data in our Jupyter notebook, we need first of all to create a tuple, and we call it markers, and then we need to create that as an empty tuple. Now this will be able to hold our markers values, so you do that. Then after we create our markers, we need to iterate through our feature classes. That because you see this is not a single, it's a feature collection, it has so many features, so we need to iterate through our data using the features dictionary here. So we come into our notebook, so we say for a feature in our JSON data, in the field which is features. So what we want to do with this is for feature, sorry for that, for a feature in our JSON data, we need to be able to come in here. So what do we want to do when we get a feature? One feature. So when we get one feature, we need to get its location, and its location will be equal to the feature, then the geometry, which is this geometry here. We need to come into the feature, and then we get to the geometry, and then from the geometry we get the coordinates. So, and you can see here our coordinates are swapped to from latitude and longitude to longitude and latitude for our Geojson. So we need to be able to swipe that aloud. So we need to get here to our netbook. We get from feature, we need to go to geometry, and then from geometry we need to get the coordinates, and as we said, we need to swap the coordinates, so we swap it using this formatting. Just do that. And that gives us our location for each of the features. Then another thing we need from our features, we need to be able to get our pop-up. Our pop-up will be equal to the HTML class that we imported here. And then we want that to be, say, a h4. That's a header tag. So we need to wrap the h4 in quotes. So then from here we need to add the feature that we have, and then from the feature, what we need to add from the feature is we need to get from the feature and then properties and then market. So we come in here, we go to feature, and from the feature we need to get the properties, and then from the properties we need to get the name of the market, which for us will be market. So this goes inside our file here, goes from it gets from the feature then into the properties, and from the properties it gets for us the name of the market here. And we need to remember to cross our h4 tag. Now that gets interpreted as a h4 header by IPyRefresh. So you do that, you cross the h4 tag. Once you have a nice pop-up for each of the points. Then the other thing we need from this is we need to be able to create now the marker from this feature. From the properties that we have gotten. So you need to create a marker, and we call in the class marker, which we imported here. This is the marker here. So you do marker. It requires some few parameters, one of them being location, and this location will be equal to this location here. So another we need for the location will be the pop-up. Will be again equal to our pop-up, which is this pop-up here, and then we need to give it a name, which will be equal to markers. So this iterates through the feature, and from the feature it gets the location, the pop-up, and then it creates a marker from the location and the pop-up. Now that we have created the marker, we need to be able to add the marker into our tuple here. So we will call this marker. This marker's here, and then we need to add the value of this marker here into our tuple. So that then that means will be markers, this empty tuple, and then you add a marker. This is this marker here. So, and then remember to, after the loop is done, then we will have a full these markers here. The empty tuple will be no longer empty. So then we come in here, so we can run that. And then the next thing we need to do is being able to create a marker cluster from these markers here. So one thing we need to do, we need to come here and then create a marker cluster. And then this marker cluster will be equal to marker cluster, this class here we imported, and we need to be able from this we need to also again get some few parameters, one of them being marker, and this marker in our case will be equal to this tuple here, which has been populated through this function, this iteration here. And then we need to give it again a name, which we want to call it, say, Kenya markets. And another one here. After creating the marker cluster, then we need to add the marker cluster into our map layer. So we come in here, do map dot add layer, and then we need to add the layer marker cluster. Then you do that. Then you come in here and learn your map. Your map will look like this, and you can see all these points have been clustered together. And then if you try to scroll down, you can see all these values that have been added. And then if you click on one of the points, you can see the name of the market. And then that's how you add marker clusters from a shapefile onto your map on IPyLeaflet. Thank you for watching this video. Next week we'll be looking at how we can convert our points into Google Earth engine points that we can use for machine learning on our Jupyter notebook. So subscribe so that you can be notified when this video comes up live. And thank you for watching. Bye.